Good evening, Sam. Oh, very well, thank you. It's a very good day, although the weather's not being the greatest. But then again, we are at the start of January, so I suppose it can only get better.
So that's I can see what that may have been. So hopefully now people can hear me. We will just quick recap. We're going to go through answering as many questions as we can tonight, but the advice and guidance that we give to the questions asked will be limited by the extent of the information provided in the question. We can't assume any liability to anyone for any loss or damage caused by any error or omission in any advice or guidance that we give, whether such an error or omission is the result of negligence or any other cause, and if we do refer to legislation, it can't be considered as legal advice. As always, individuals must rely on their own skill and judgment when making use of the guidance offered. Please do put your questions into the chat and we'll try and get round as many questions as we can. Please be respectful to each other in the chat, as the whole idea of this evening is that collectively we're going to help each other with the aim of improving our collective knowledge of all things BS 7671 and electrical. So please do post your questions into the chat. As always, we'll start with the question of the week, which we posted out on Monday. So the question this week was, BS 7671 states that the volt drop between the plug of a towing connector and a caravan's auxiliary battery should not exceed, and then we gave four options. It was either A 3%, B 4%, C 5%, or D a 0.3 volt value. We did have a little look earlier in the week to see what people were voting at that time, and when we looked quite early on Monday, we could see that there was a rough split. 38% had gone for 0.3, but 30% had gone for 3, and 24 had gone for 5. So there was quite a mix. So what is our answer there, Craig? What's the definitive answer?
So the answer to this one is actually D, 0.3 volts. I do understand. I mean, some of the confusion. You like to pick questions, especially this one, Sam, where you've got to delve into the regs a little bit. Now, there are some key points in that question for where we need to look at, and the main part of that question is to do with towing vehicles and caravan auxiliary batteries. So, for this answer, we're actually looking at the annexes, or the annex in section 721. 721 being for the electrical installation in caravans and motor caravans. And there is an informative annex, which is A721, and it's 525. It does state in the volt drop between the plug or the connector to the towing vehicle or LV battery charger and the auxiliary battery should not exceed 0.3 volts. I do see why people are putting A and C in relation to 3% and 5%, because they're the voltage drop percentages that we would generally find in the body of 7671. So it was a nice, not trick question, but making sure people are on their toes reading the question. So it was a really good question that we posted out there to get people thinking about where in 7671 we should be finding this answer.
Yeah.
There's also guidance in the voltage drop in consumer installations of caravans and motor caravans, which says, under normal services and conditions, the voltage at the terminals of any fixed current using equipment should be greater than the lower limit corresponding to the British or harmonised standard. Where there is no standard or such that exists, then we've got to make sure that it's for safe function, which may be up to 0.8 volts as well. So there's some difference in information in that particular annex. So yeah, really good question for that one. And it was one of those ones which is always trying to find it comparatively to the body of the standard, always a good one. So
yeah.
What I thought was
yeah, and because I think you're right, we're very used to the 3 and 5% values, and so to have an actual magnitude, an actual voltage, is a little bit unusual. But yeah, thought it was a good question, and as you say, a lot of those questions are aimed at getting people to actually look in it, because as we've said many times, the amount of times when we're looking for something and we find something else and we go, oh my God, I didn't know that was there, and then somebody tells you that's been there since 1980. So yeah, it's amazing, our world, and if anybody ever tells you they know it all, walk away, because it's just impossible. Okay, great start. So yeah, please do put your questions into the chat and we'll get round to as many of those as we can. While we're waiting for those questions to come into the chat, we'll just have a look at a few more that were hung over from previous sessions. So the first one of those is a common question we get. In a TT installation, do I need to protect the incoming tails to a metal distribution board with 100 milliamp RCD? So I think people often get very, a little bit confused with, on a TT system, everything has to be RCD protected, doesn't it? And so we quite often get asked this question. And the answer is no, they don't have to be. And there's a regulation that tells us that. So if we look at, it's quite a long regulation, 531.3.5.3.2.201. So that tells us it's a UK one. And we've got it on screen. It tells us that for class 1 enclosures, so metal conductive enclosures in TT systems, where we've got RCD protection on all the outgoing circuits, so all the final and distribution circuits from our distribution board have got RCD protection, or they've got reinforced insulation of all live conductors, including the incoming cables, extension terminals, etc., on the supply side of the incoming device, e.g. the main switch, shall be used, then insulated and non-metallic sheath cables are deemed to meet the requirements of double or reinforced insulation. So long as we maintain that double insulation of the tails of the feed to the distribution board, and that's maintained all the way up to the main switch, then we're deemed to be okay, and we don't need to provide protection. We used to, not so much now, but we used to get a lot of people would actually put 100 milliamp RCD main switch in the board, and again, that wasn't required, and all that was doing was protecting those connectors between the main switch and the distribution within the board. but it's not a requirement. There are some further notes that go on which are important, which talk about when we select equipment, consideration should be given to the assembly manufacturer's internal line interconnecting cables, and because there's a requirement for the degree of insulation, we can't go making our own cables, using our own cables, so we're required to use the manufacturer's cables in order to ensure that we're complying with their requirements to maintain the required degree of protection. And as note 2 says, only the assembly manufacturer's approved internal interconnecting cable links should be used. Would you add anything to that, Craig?
Yeah, so read the manufacturer's instructions as well for this, because there are some manufacturers that will stipulate that a possible dual RCD board, because of the nature of the links between the main switches and the RCCB units, may well only be single insulated and not necessarily double insulated or reinforced, that they may not have manufactured them to be suitable to be installed on TT systems. So as part of that, definitely have a look at the manufacturer's instructions to see if there's any information on there as to what earthing system they've been tested to be installed on, to make sure that the internal wiring meets the degree of protection, either being double or reinforced within the wiring links, which is why the note 1 is there to do with the interlinks between the main switch and the RCCB units.
Yeah. So yeah, a good question, and one we used to get a lot. We still do get it fairly frequently, but not so much nowadays. But yeah, so it's not a requirement so long as we maintain that double insulation of the tails or the supply to the distribution board or consumer unit. Another question, again, is a common one that we often get. So, can I fit a 230-volt towel rail at the end of the bath, so it would be in zone 1 of that location? So, can I put a 230-volt towel rail?
Yes, we can. Yeah. So again, we're in the special locations this time around. We're in section 701 because we're looking at a location that contains a bath or shower. And it's 701.55, which is to do with selection and erection of equipment, other equipment. And it does state in there in zone 1, and there is quite an extensive list that is suitable to be installed in zone 1. And there is a caveat that I'll kind of explain in a second. And it is indent IX, clearly says towel rails. It's worth noting that in the body of that regulation, it does say that provided it is suitable for installation in zone 1 according to the manufacturer's instructions. So you would have to make sure that the manufacturer's instructions clearly state that the piece of equipment is suitable for zone 1. You would also have to make sure that in that particular piece of equipment meets a degree of protection of IPX4. And possibly IPX5 if there's going to be splashing or sprays in relation to the top of that page from memory within 7671.
Yeah, so it is permitted, and I think it, again, a lot of people were under that sort of misconception that you can't have anything 230 volts in the bathroom, and you can, and like you say, there's a nice prescribed list of things which can be, providing they are suitable for that environment. So as you say, they've got the right IP rating and they're installed with manufacturer's instructions. And there's you know, that list includes luminaires, it includes showers, and as you say, it includes towel rails. So yeah, spot on.
It's important to actually, yes, electric showers, ventilation equipment and luminaires. You know, these are generally 230-volt pieces of equipment, and we want to make sure that we don't just blanket rule and say that, oh, they're 230 volts, they definitely can't be set there. The manufacturer has clearly stated in their instructions that they are suitable for zone 1 and they meet the appropriate IP ratings, then they can be installed in such a zone. So, yeah, that nice prescribed list in 701.55 is crucial for understanding equipment that can or can't be put into zone 1 of a location containing a bath or shower.
Yeah. Okay. question 3. Are domestic kitchen appliances required to have an isolator for compliance with BS 7671, the requirements for electrical installations? Yes or no? Again, a common question we get, and the answer is that yes, they do have to have a means of isolation. And if we go to our let me just throw the right slide up, sorry. Go to our fundamental principles section. So we're right the way back at the beginning of the standard, and it clearly says one of our fundamental principles is that everything effective means suitably placed, which we'll talk about in a minute, for ready operation shall be provided so that all voltage may be cut off from every installation, from every circuit thereof, and from all equipment as may be necessary to prevent or remove danger. So that tells us that everything has to have a method of isolation. And it does further. The definition of equipment says any item for such purposes as generation, conversion, transmission, distribution, or utilization of electrical energy, such as machines, transformers, apparatus, measuring instruments, protective devices, wiring systems, accessories, appliances. So that's where, so that clearly falls in line with the question, do our kitchen appliances? So definitely yes, we do need a means of isolation, but we need to clarify a little bit. So BS 7671 doesn't say that it has to have an independent means of isolation. So we could, for example, use the overcurrent protective device, probably a circuit breaker that's in the consumer unit feeding that kitchen circuit. Now obviously that would then mean that you'd isolate the whole circuit and not just that appliance, and that might be a problem for maintenance or general use. So you might choose to have independent isolators, but it's not a requirement of 7671. 7671 just says there has to be a means. It does use those words suitably placed, and when people ask us about that, we kind of explain, well, look at the potential dangers. So if you've got something that's dangerous and moving parts perhaps, and so we might get entrapment or entanglement for the users or the operators in that area, then you might want a local means of isolation which immediately shuts off all energy. But if it's not so dangerous, maybe you've got a fan which is high up and can't be touched or could result in entrapment or entanglement for the users, then maybe that then could have an isolator away from it. The requirements in 7671 say clearly that if the isolator isn't local and easily identifiable, then it does need to be labelled to make it clear what it is doing. But yeah, it does have to have a means of isolation, but doesn't have to be independent, doesn't necessarily have to be local, but should be suitably placed based on the potential hazards. And furthermore, there is a table within BS 7671 537.4 that provides guidance on which things can be used as isolation, because there are specific requirements, dimensional requirements associated with the contacts of things that can be used for isolation and some things can't. Would you add anything to that, Craig?
Well, you mentioned during that you talked about removing unexpected dangers. So we've also got to look at, this question talks about the need for isolation, but you've also got to look at the need to remove unexpected dangers where you might need emergency switching off, which is not necessarily the same as isolation in the sense of isolating and working or maintaining that piece of equipment. So there are differences in Chapter 53 around what equipment that you, or switching or isolating or emergency devices that you can use in those circumstances and when you might have to apply them. So kitchen appliances, and this is very dependent on the designer of the installation, may look at pieces of equipment and may warrant a level of protection to do with emergency switching off if you feel like there is a danger there, and therefore you have to meet certain requirements for the isolation device within table 537.4 and what can and can't be used. But yeah, as a general rule, isolation devices are needed, but they're not necessarily needed locally, as you say, Sam. They're not necessarily needed to be placed, above the kitchen counter or even in the kitchen cupboard. It can be the protected device that actually services that particular circuit feeding that piece of equipment.
Yeah. And it's quite fortuitous because one of the questions that's come in tonight is on this subject. So one of the questions that's come in from an engineer in the audience tonight has said, does a 3871 device provide isolation? And they've added, looking at 3871 standard, could not find a gap. Just a 2 kV, which 60898 has 5 kV and a 3 mil gap. Refers to regulation 531.1.1, mentions devices for protection of electric shock required to be suitable for isolation. I'm just looking at, because 3871s of course are no longer, I'm just trying to check, but I don't think they're any longer in 7671. No, they're not. So although that reference that we're showing there is to table 537.4, that's only for existing or products with an existing reference within 7671. So I'd need to do some more work to find that out. But I've got, I don't like to guess, so I won't say, but I don't think... Well, yeah. Let me do some investigation on that for the member tonight. So we're not going to be able to answer that tonight. We'll come back because I just need to have a look at the old standard for 3871s, which I don't have to hand at the moment. But yeah, as they've mentioned in the question, it really is down to do with the physical gap between the contacts when they're open, as to whether it meets the requirements for isolation.
Which is why a plug and socket, generally speaking, can be, because once it's unplugged,
yeah,
depending on how far away the plug is away from the appliance, it's just unplugged.
Yeah,
would meet the minimum requirements of that 3 mil gap.
Yeah, and certainly modern day breakers, so it's at 60898s, and also I'm looking at 60947-2s, and also the RCD 61009 version. So all of those can be used as isolation. They're all confirmed in that table 537.4, which is on page 184. Unfortunately, 3871s aren't in that table because 3871s aren't referenced in 7671 anymore.
And we'll have to check to see if the gap between the open and closed meets the requirements within 7671 to be classed as an isolator. So that's why Sam has quite rightly said, let's do some research on that. Let's have a look at that. Let's not get that wrong off the cuff.
I mean, the first thing I'll probably do, although not immediately now, but after tonight, is go back in 7671 to a stage where 3871s were included to see if there is an equivalent to the 537.4 table, because that'll give us some information as well.
Yeah.
Okay, so yeah, good, and I broke out because I thought it was opportune because it was same subject. So we'll pick up more just as we're. So please do put your questions into the chat. One other one that was hanging around from previously is it permissible to install electric vehicle charging equipment within a meter cabinet? So again, a question that we get asked a lot, and we've been into print and there is information out there. What's our thoughts there, Craig?
So we have the Electrical Safety First website, and it's one of the RAG questions, which is the Wiring Regulations Advisory Group, and they have a set of Q&As in relation to industry guidance for this. And the answer to this one is actually no. So it does talk about, give an explanation of where this applies. So whilst the meter cabinet is owned by and is the responsibility of the homeowner, the space within the cabinet is designed for the use of electrical industry apparatus only, and no allowance is made for additional equipment to allow safe access for maintenance or replacement. So for this reason, it's strongly recommended that such items of electrical equipment are not installed within a meter cabinet. So there is a connections article that was also done in the winter of 2021, which gave the same advice around the same subject. And we are also aware that there have been instances where the supply authority has actually requested that the equipment be removed from meter cabinets historically.
Yeah. So it's a real no-no. The consumer, the contractor, nobody should be installing anything in that enclosure. It's designed for the metering equipment, and they'll get very bent out of shape if we start using the spaces that are assigned. So yeah, if you are an NICEIC contractor, please do go and have a look at that article. Really good. A little bit old now, 2021, but still 110% relevant. Really good.
And if you're looking for the question number in the ESF website, it's question 1.137.
Right.
It talks about installation of EV charging equipment or other items of equipment within a meter cabinet.
Yep. Okay, another one that we get asked a lot, obviously when people are completing installation certificates. So when completing an electrical installation certificate, are light switches counted as an electrical point with respect to the number of points served? Nice easy answer for us there. The answer is no. The number of points served should be the number of items of current using equipment connected to the fixed wiring. So on a lighting circuit, the switches aren't current using, it's only the luminaires themselves. Similarly, a pendant lamp holder with one lamp or a chandelier with multiple lamps, they're both considered as the same point because they've got that one connection to the fixed wiring. So that would only be considered as 1.2, and likewise same principle. It doesn't matter if you've got a single or double or even triple socket outlet, they all count as 1 point because they've got one connection to the fixed wiring, and that's the definition. It's a current using equipment with that's got a connection to the fixed wiring. So if it's an appliance that then has got some internal distribution like a double socket or a three-way socket, it would still be counted as 1 point. Still getting those questions, Craig?
Yeah, I'll still get those questions from contractors, and I'm always pointing to part 2, the definitions of point. The definition of point is the intended connection of the current using equipment for the electrical installation. So where you might have a flex outlet plate and a fuse spur for maybe an integrated piece of equipment, it would be the outlet plate connecting to the fixed piece of equipment and not the fuse connection unit or the double pole switch isolator or the light switch for the point served. The only caveat to that one, because we've talked about switching appliances recently, is if you've got possibly a cooker outlet plate that's got a socket outlet as part of its connection, and then a cooker outlet for your connection of your oven or your hob, then obviously you have a socket outlet on one, and then you have an outlet plate for the connection of the current equipment there. So in that regard, you would have two, but if it's just a switch and an outlet plate, then it would just be one.
Yeah. Okay. And another little bit of a thorny question that we quite often get asked, very similar for installation certificates. So I've completed a periodic inspection and test of a building. However, I'm involved in a contractual dispute with the client. Can I object to issuing the EICR until the dispute is over? So we're going to answer this purely from a BS 7671 point of view, not from any contractual. So what's our response there, Craig?
So for compliance with 7671, the answer here is no. So you must issue that conditional report.
Yeah.
So you can't object to issuing the EICR if you've completed those works. Under 7671, it says the report shall be issued to the person ordering the inspection and testing. Therefore, for compliance with 7671, the report should be issued. So that's regulation 653.6. You should inform the client of any immediate actions that need requiring in writing, such as code 1, danger presence. And one way of informing them may well be the issuing of a danger notification. So 7671 doesn't include to act as contractual advice or for contractual disputes. So we're only going to talk about, for 7671, same with an installation certificate. You shall be providing that certificate on completion of such works.
Yeah. The danger is if you don't, then you'll be accused of not having complied with the British standard for the work that you're doing, and then that, if things do turn nastily, then that will really be held against you, because that's the standard to which we should be working. We do appreciate it's very difficult, and sometimes people feel that that's the only thing they've got, which is why you do need to get, if it's a payment issue, then get those things ironed out contractually, that that you'll get your stage payments, which means then that that once you issue that, then you're entitled to a stage payment associated with it. So but we can't, our advice has to be around compliance with 7671. That's what we assess to, and so our advice is always that no, you can't withhold the report or the certificate. Also worth saying that particularly if you've got classification code C1's danger present, you need to make them aware, inform the client in writing immediately. One good way of doing that is to use electrical danger notification to do that, and of course you would record it on the report as well. Difficult, we know. We appreciate that sometimes people feel that's the only bargaining chip they've got, is to withhold the certificate or the report, but our advice is you can't do that, because then you'll fall foul of compliance with 7671, which would be used against you at a later date. Looking at some of the questions that are coming from the chat, there's some great one that's came in very early is with regard to ambient temperature, CA, when designing a circuit and with the absence of any usable information beforehand, what's the default ambient temperature to use when circuits run through a loft space? Difficult one for us to give a definitive answer on. What I would say is, if you look at the rating tables for ambient temperature, then the de facto temperature where there's no rating, i.e. it's a rating factor of 1, is 30 degrees. So and that's based on because the circuit running will generate heat into the cable as well. So you can understand that it may be higher than ambient temperature, which people would normally consider to be sort of 20-22 degrees. But you do need to think about it, and if it is actually colder, which the loft may be, depending upon level of insulation, if it's colder, then the same size cable will actually carry more current, because it will have a higher rating factor. It will be greater than 1. So there is no real one. For example, if we look at 70 degrees C thermoplastic. If it was 30 degrees, then CA rating would be 1. If it's 25 degrees, then it'd be 1.03. So that's 3% more current that cable's going to carry. So very difficult to know if especially if it's a new build. You don't know what it's going to be, how much insulation is going to be. But yeah, just be careful that we're not talking about cables that are in the loft covered in insulation, because that's very different then. But yeah, you've got to make an estimate. If you're unclear, then using that 30 degree or 25 degree if you wanted to go a bit lower, or even 20. But yeah, really try and get some information from a common installation to see what temperatures are involved, and be very careful about or make sure that you consider and ask questions around the degree of insulation, where the cables exactly are going to be installed, because if they're underneath insulation, then temperature differences will be much bigger.
Yeah, well, that's CI, isn't it?
Yeah.
If it's in insulation, it's CI, but the question's talking about CA, which is ambient temperature. So if your cables are kept away from the insulation in the loft, you've got to look at the temperature of the air, the ambient air temperature around the conductors, and not necessarily the insulation that is around the conductors and how that affects the cable's ability to carry current.
Yeah.
So the ambient temperature, I mean, lofts do get hot, but not that I've ever taken a thermometer into a loft from all the years I've spent in lofts for all of my sins. 35 degrees, probably the highest I've ever probably got into a loft. A lot of it is humidity, a lot of it is not a lot of free air movement, so you feel a lot hotter. You're normally working quite hard to get cables from one end of the loft to the other. So you as an individual feel very warm. But actually, from an ambient air temperature perspective, it actually might not be massively hotter than the 30 degrees ambient air temperature, which is the standard 1 deviation.
Yeah, and you're absolutely right. I'm thinking of cold because it's cold at the moment. Having just put Christmas decorations back into the loft, realising how cold it is. But as you say, come July and August, the loft will probably be the warmest part of the house. So yeah, there's quite a temperature range there, isn't there, over the year. Yeah. A couple more questions. So one that's I've just pigeonholed the right bit in 7671. So question from a member of the audience tonight: a socket outlet complying to BS 1363, so a sort of a standard socket dedicated for EVSE charging. Do the requirements of 722.411.4.1 need to apply? One thing I would say is that if you do look, so within the vehicle charging special location section 722, if you look at the socket outlet and connectors section, which is on page 328, it does talk about you can have one socket outlet, but it must comply with BS 1363-2, and it marked EV on its rear. So it's a specialist, but your question just left it open to BS 1363 series. So for EV, it must be compliant with 1363-2, and it must be marked EV, and then all of the other requirements within 722 would still be applicable. So 411.4.1 then is if there is a PME, if it is a PME supply, then we need OPEM protection, or we need one of the other permitted methods of protection against electric shock. But yeah, it would still apply. It does if you are using a 1363 socket. It doesn't have to be dedicated electric vehicle charging equipment.
Yeah, 411.3.2.3 talks about the requirement for your loss of neutral, essentially, on PME facilities. And it doesn't particularly stipulate the difference between the type of socket or connector arrangement. So therefore, as Sam quite rightly says there, is that it would still apply to that type of connection type.
Yeah. Okay, and another one that we often get asked, and it's a hot subject. Evening, Sam and Craig. Quick question on an addition to a kitchen. If you was either adding an extra 2 sockets or a new circuit with 2 sockets into a kitchen area, and the fuse board had a type AC RCD, would you have to replace the RCD to a type A RCD? If we take it in 2 parts, if you were adding a new circuit with socket outlets, then your new circuit needs to comply with current regs, and current regs would then say, unless we can confirm the type of equipment that we're going to be plugging in, which if it's a general socket outlet is probably not going to be the case, then we wouldn't be able to use a type AC. And likewise for the 2 additional sockets. This is one of those situations where at the moment we're talking with others in the industry about additions and alterations, and sometimes the requirements for compliance with 7671 for additions and alterations are quite onerous, because now we've got situations whereby if we're adding 2 socket outlets, then strictly speaking those 2 socket outlets need to comply, the additions need to comply with current standards, and current standards would say socket outlets, unless we can confirm there's no DC components, are going to need to be protected by something other than a type AC. But
that's only for fixed loads.
Yes.
True.
Yeah.
Says for fixed loads, for socket outlets, there is no caveat to that. So for a socket outlet, because we don't know what could get plugged into that, would have to have the type RCD on it.
Yeah.
If it was a alteration to an existing circuit, and correct me if I'm wrong here, Sam, because I know this one's an open one in the industry at the moment. If it was an alteration to an existing circuit where you're adding no additional DC component, such as possibly altering a circuit that then maybe does like an immersion heater, as an example, no DC components there, then you wouldn't have to apply the A type RCD. But all the time it's a socket outlet in 53, chapter 53, it says that AC type RCD can only be used for fixed equipment where there's no known DC components.
Yeah. No, you're absolutely right, and thank you for that. We appreciate it can seem now, because now whereby you might have told somebody, well, it's just the addition of 2 sockets and worked on it based on that, and then when you go there you find that there's a type AC in the board, and now you need to change the RCD, and then perhaps that involves different, because there might be a manufacturer that doesn't produce one, or the size may be different, so it can have a real domino knock-on effect, and we appreciate that. And there's a lot of work being done within the industry now to sort of see can we do something around that. Obviously at the moment it's pretty clear, 7671 is very clear. Again, if we go back to our fundamental principles, it says right at the bottom of page 20 that the regulations apply to additions and alterations to installations. So if you add something, even though the existing installation may have been designed and installed to a previous standard, your addition and alteration has to be compliant with the current standard, and we appreciate that can be very onerous at times, because now it's not as simple as just adding a socket. You may need to change the RCD. There may even be instances where you need to change the board, and that's where we sort of think that it can be difficult, and what we don't want to do is drive the black market of Dave down the pub will do it for 50 quid with no certificate if we make things too onerous. So yeah, at the moment, for compliance with 7671, you wouldn't be able to add sockets without providing them with RCD protection, not via a type AC. So that's the way it is at the moment. But as I say, that is being looked at within the wider industry as to the best way forward, because as I say, we don't want to make things too onerous, such that then we drive the black market, and then we're not actually aiding and helping people to fully comply with 7671, which is what we want people to do. Yeah, so a difficult one. I mean, one thing, if it is a real issue and it does become a problem, you can think about if you used RCD socket outlets that were type A, providing the cable then feeding them doesn't need RCD protection. So you would have to, for example, surface mount that cable in trunking. So that's an alternative, but yeah, otherwise it is going to be a case of changing the type AC for a type A. Okay, we're very quickly running out of time again. We'll see if we can take another one from the floor. It's great questions, actually. I do thank you, and if we don't get round to asking your question tonight, we do apologise, but what we'll do is we'll hoover that up when we come to the next session. So one that's just, if we get an electrical control panel and pipework installed over the top, should the panel be protected with I guess it's saying drip trays in case the pipe work breaks and the seal's leaking? So if we get an electrical control panel with pipe, so difficult one to see without sort of seeing, but there's some, again, we've referred back to fundamental principles a lot in tonight, and personally that's really pleasing, because I think that's where we should all start. 7671's written that way, such that you should actually start from the front of the book and make sure you're complying with those fundamental principles before you get into selecting the equipment that you're going to install and complying with parts 5 onwards. So again, there's a fundamental principle that says everything we install should be suitable for the environment in which we install it, or the way we install it makes it suitable for that environment. And so that applies there. So if we've got pipe work, and the pipe work shouldn't, but we might, in order to make it a robust design, we'd cater for issues with that pipe work by putting something above. It's not a hard and fast requirement, although there is, again, there's a regulation set which talks about where we've got electrical equipment installed in close proximity to non-electrical equipment, and then it gives us two options. We can either distance them so that they're so far apart that there's no detrimental effect between either, or we can put physical barriers in between so that there's no. While I'm trying to find that, would you add anything to that, Craig?
Yeah, so as you quite rightly said there, Sam, we've got to make sure the equipment that we install is suitable for the environment in which it's placed. And to some degree, we've got to understand that pipework isn't designed to leak. That no one puts a new pipe in above your piece of equipment or near your piece of equipment in the hopes it's going to burst and leak everywhere. Otherwise, which steps do we then take when you've got pipes running through your house and in your ceilings? Does that mean all the sockets in your house have to be IB rated and externally rated, or IP65 or IP66 sockets? Sounds like it's no. So a consideration there, by the sounds of it, there's a panel and there's pipes nearby. You've got to look at condensation. You've got to look at the environment in which it's placed. Is there high humidity? Is there likely that actually drips, and the environment in which it's placed may not have rain or spray or anything applied to that piece of equipment? However, the nature of the location and equipment there in high humidity and a cold water pipe may mean that there is a risk of high humidity content and water content in the environment that may need the equipment or the way we install the equipment being suitable for that particular area and the type of water or egress that you may be present there. But I can't see the questions from where I'm sat. I'm just sort of going by what Sam was reading to me. But yeah, there's nothing in 7671 that predominantly says that if you've got a pipe nearby, if it's carrying water, that you have to put drip trays in the panel or what have you. That may differ dependent on the panel manufacturing, panel wiring standards, which are different from 7671. You mentioned panel there, Sam, so but I'm sort of thinking consumer units, distribution boards, and such like that. There's no need to have drip trays in those, but the panel and manufacturing process for equipment such as panel wiring might be slightly different.
Yeah, and you're right that they have said control panel. The two regulations that I was thinking about, the one 528.3.3, which is in the section proximity to non-electrical services, and it talks about when electrical services to be installed in proximity to one or more non-electrical, it shall be arranged that any foreseeable operation carried out on the other service will not cause damage to the electrical service. This may be achieved by suitable spacing between the services or the use of mechanical or thermal shielding. And then the fundamental was 133.3, electrical equipment shall be selected so to withstand safely the stresses of the environmental conditions and the characteristics of its location. Any item of equipment which doesn't by design have the properties corresponding to the specification may be used where adequate further protection is provided. So as we said, it should be suitable for the environment, or the way that we install it makes it suitable. And yeah, I think, you know, if you want to try and make it as maintenance free and as robust as possible, then factor in those errors that may occur with those other non-electrical services.
I think a lot of the questions that we're getting today and the questions that we've had on the chat specifically really make us look at the fundamental principles of 7671, and as designers, how we then achieve that. And 7671 isn't a rule book that you blindly follow for every possibility of installation, because there are such permutations and differences and nuances within electrical installations that we want to look at the fundamental principles, what we have to achieve, or what the intention of 7671 is there for. And then as designers, we look at ways to engineer the best course of action for that piece of equipment in that area under those circumstances. So it is a design guide. It is a book there that is used to help the designers and the installers to comply with the requirements of the British standards in relation to the fundamental principles, which is electrical safety and compliance of that installation. So the questions that we've had have been really good in the sense of it gets you to think about what it is to be a designer, and not necessarily a clear, concise, exact regulation, because the question here that we had about kitchen appliances, well, nothing in 7671 specifically said kitchen appliances. However, in the fundamental principles, it says that we have appliances that need to be isolated. So we apply that particular requirement to all appliances and not just specifically kitchen. So I think people get stuck on, oh, does my kitchen oven need it? Does a dishwasher need it? Do a tumble dryer need it? Does a piece of equipment? Look at the fundamental principles and then have an understanding of how the regulations are designed to be read front to back and understand what they're there to achieve. And then you can look at the body of the regulations to make sure that you're designing that installation to best service that end user and the usability for the lifetime of that piece of equipment or installation. Yeah. So really good questions tonight, I think.
Yeah, and you make a really strong point in that, yeah, if we tried to cater for every different variation and nuance, we'd have 100 books or more. So yeah, it gives us those fundamental principles, and then we need to think about how which ones are applicable, which ones are relevant to the work that we're doing, and how do we meet the requirement. So yeah, it's a really good point.
It's very slightly off topic, but is topic. So the NEC rules, which are the rules that they use in America, I'm a bit of a geek when it comes to standards. Their documents are about 3 to 4 times the size of 7671, and are very much you do this in this circumstance and you must do this in this circumstance, rather it being a prescriptive document rather than a descriptive document.
Yeah.
Because otherwise there are situations where you might come across and go, well, what do I do here then? And as designers, it's our job, your job as the installers and the designers, to best apply your engineering judgment to make the best call in that circumstance.
Yeah. Okay, just before we go, we're just going to run through a few things. So if you're not currently certified with NICEIC and you would like to be for with electrical schemes, MCS, non-electrical additions such as hazardous area, fire alarms, then yeah, please do go to our website to obtain information or contact our customer services. Likewise, if you've got training requirements, so again, electrical training, renewable, emergency lighting, fire alarms, then please do get in touch with us, either directly through the website or again through customer services. Just want to make you aware of some events that are coming up. I know it sounds crazy talking about March already when we're only in January, but some dates for your diary. ELEX shows start again in March. So first one this year is up in Bolton. That's on Thursday and Friday, 5th and 6th of March. And then at the end of that month, we're down at Alexandra Palace. So the NICEIC stand will be there. Please do, if you're in those areas, come along and see us. We'd be more than welcome, and we'd love to talk to you and find out what you're doing and what's happening. We'll be back with another open Q&A on the first Thursday of February. That's Thursday the 5th of February at 8 o'clock. So as I say, really thanks for everybody's contribution tonight. As Craig said, some great questions that have come in. We've tried to answer as many as we can. Apologies if we haven't got round to yours, but we do get hauled over if we go over the hour, so unfortunately we can't do them all. But if we haven't managed to go through yours, we'll use one of yours as the start up to the next session. If we don't post it out as a social media question, so please do, if you're not already, look at our pages on Facebook, on Instagram, on LinkedIn, on YouTube. We do post a Q&A out every week, so we tend to post the question out on Monday, and then on Thursday or Friday we'll give you our answer together with our rationale for it. So as I say, if we haven't got round to your question tonight, we'll either use it as one of the social media questions in the coming weeks, or we'll answer it at the start of the session next month. Anything you'd like to add as final words, Craig?
Don't get too cold and don't fall over out on the ice. Be safe out there, because I know there's some storms coming across the UK, so safety first, everyone. Yeah, really good. Yes, be safe. There's only one of you and we want to see you back, definitely. So thanks very much. Thanks for everybody's contribution tonight. Really enjoyed it, and hopefully we'll see you again next month. Thank you.